Good morning, students. So today we are going to see the problems on related rates. So exercise 7.1, fourth problem. If the volume of a cube of side length x is v is equal to x cube, find the rate of change of volume with respect to x when x is equal to 5 units. Okay, so here it is given the relation v is equal to x cube. So what is v? V is nothing but the volume of a cube. Then what is x? X is nothing but the side length of the cube. So x is the length of the cube, side length of the cube, and v is the volume of the cube. So from this relation, v is equal to x cube. So v, the volume, is depending on the variable x. If x changes, there is a change in the volume. Okay, you see the question what is asked? Find the rate of change of the volume with respect to x. You see the word rate of change of volume with respect to x. A rate of change, if it comes, you have to use the derivative. So here the volume is denoted as v. The rate of change of volume with respect to s is denoted as dv by dx. So what is dv by dx? It's a rate of change of volume with respect to x. But what we have to find? We have to find dv by dx when x is equal to 5 units. So I consider the given result v is equal to x cube. So you are going to differentiate with respect to x. So dv by dx is equal to, how to differentiate x cube? So it is nothing but 3x squared. Okay, so here dv by dx is asked when x is equal to 5. So in the place of x, you have to substitute 5. So 3 into 5 the whole square, that is 5 squared is 25. 3 into 25 is 75. This is nothing but rate of change of volume with respect to x. Okay, with respect to x. Okay, come to the next problem. If the mass m of x, that means m is denoted mass, it's a function of x. Okay, so if the mass m of x of a thin rod of length x, okay, mass is in kilograms and the length is in meters, is given by m of x is equal to square root of 3x. Then what is the rate of change of mass with respect to the length? Rate of change of mass with respect to the length when it is x is equal to 3 and x is equal to 27 meters. Okay, so what's the relation given? M of x is equal to square root of 3x. Okay, so the square root of 3x can be written as root 3 into root x. So m is what? M is the mass, and what is x? X is the length. Okay, so m, the mass, is a function of x. Okay, so here what is asked? You see the question, rate of change of mass with respect to what? Length. So we have to find out dm by dx. Okay, so that is equal to root 3 is a constant. So we have taken out. Here you will have root x. How to differentiate root x? You see that the differentiation of root x can be written as x power 1 by 2. So that is equal to. So using the x power n formula, the differentiation of x power n is n x power n minus 1. So it will become 1 by 2 x power minus 1 by 2. So that can be written as 1 by 2. So x power minus 1 by 2, when you take it to the denominator, it is x power plus 1 by 2. So x power 1 by 2 can be written as it is root x. So the differentiation of root x is nothing but 1 by 2 root x. So root 3 into 1 is root 3 by 2 root x. Here what is asked? The rate of change of mass with respect to the length when it is x is equal to 3 and x is equal to 27 meters. So you have to find out dm by dx when x is equal to 3. So in the dm by dx you have to substitute x as 3. So it will become root 3 divided by 2 root 3. Root 3 getting cancelled. So your answer is 1 by 2. Okay. Mass is in terms of kilogram. And your x, what is the length is in terms of meter. So 1 by 2 kilogram per meter. Next, the dm by dx when x is equal to 27. So that is equal to, what is dm by dx? This is. So what is your x? X is 27. So when you substitute, you will get this answer. Okay. So root 3 divided by 2 into root 27, how it can be written as 9 into 3. Square root of 9 into 3. Square root of 9 is 3 into root 3. Root 3 getting cancelled. Your answer is 1 by 6 kilogram per meter. Okay, come to the sixth one. A stone is dropped into a pond causing ripples in the form of concentric circles. A stone is dropped into a pond causing ripples in the form of concentric circles. Concentric circle means, so the radius will be different, but all the circle having the same center. Okay. The radius r of the outer ripple is increasing at a constant rate at 2 centimeter per second. You see the words? The radius r of the outer ripple. So outer ripple is in the form of a circle whose radius is smaller. That radius is increasing at a constant rate. So this word is important, rate. Okay, at a constant rate at 2 centimeter per second. Okay, so from that sentence it is given as rate. The radius is increasing at the rate of 2 centimeter per second. So radius in which variable it is denoted? R. So from the sentence we understood that what is given? dr by dt is equal to 2 centimeter per second. So the rate of change of radius with respect to time. So the radius is increasing with respect to time. Yes, that is, I have denoted here as dr by dt, that is equal to 2 centimeter per second. You see, when the radius is 5 meter, radius is 5 centimeter, find the rate of changing of the total area of the disturbed water. When the radius is 5 centimeter, so radius what we have denoted? So it is r. So when r is equal to 5, what we have to find? The rate of changing of the total area of the disturbed water. So the water forming the circles. So now we are going to find the total, the rate of change of total area. So area we have to denote. So let A be the area of the circle. So here what is asked? Rate of changing of the total area. So we have to write dA by dt. Okay, that is equal to what? When r is equal to 5 centimeter. Okay, so what is the, here now no relation is given. In the previous problem the relation is given, v is equal to x cube and m of x is equal to square root of root 3x, like that it is given. But here we know that the area of the circle is equal to pi r squared. Area of the circle is equal to pi r squared. Here your area is depending on r, but in this problem the rate with respect to time we have to calculate. So you take this relation, we are going to differentiate with this relation with respect to t, because here what is given? dr by dt is given. So we have to differentiate with respect to t. So what is the differentiation of a with respect to t is dA by dt is equal to, here pi is a constant, so we have to take it out, and r squared we have to differentiate with respect to t. So r squared differentiation is 2r and we are differentiating with respect to t. So therefore the r has to be differentiated with the t. So that is dr by dt. Okay, so that is equal to 2 pi r into dr by dt. Okay, so here what is asked? Rate of changing of the total area of the disturbed water when the radius is 5 centimeter. So you have to find out dA by dt when r is equal to 5. So here 2 pi, r is 5, and what is dr by dt? Already it is given 2. So it is 2. So when you substitute, your answer is 20 pi. What is area? So area means centimeter squared per second. This is the rate of change of area with respect to time is 20 pi centimeter squared per second. Okay, so we'll move to the 9th problem. A ladder 17 meter long is leaning against the wall. The base of the ladder is pulled away from the wall at a rate of 5 meter per second. So you have to concentrate on the word rate. So when the rate comes, you have to use the derivative. So when the base of the ladder is 8 meters from the wall. So see now the first question. How fast is the top of the ladder moving down the wall? And the second one, at what rate the area of the triangle formed by the ladder, wall and the floor is changing. See now, a ladder 17 meter long is leaning against the wall. So this is the wall. Okay, so AB is the ladder whose length is 17 meter is leaning against the wall. See, the base of the ladder is pulled away from the wall at a rate of 5 meter per second. So to denote this, we need some variable. So here first AB is the ladder. Here I am going to denote X. X is the distance between the wall and the base of the ladder or the bottom of the ladder. What is X? Is the distance between the wall and the bottom of the ladder, or we can say the base of the ladder. And what is Y? Y is the distance between the top of the ladder and the bottom of the wall. So A ingrathu top of the ladder and here it is the bottom of the wall. Okay, so X is this distance, wall and the bottom of the ladder or base of the ladder, and Y is the distance between the top of the ladder and the bottom of the wall. Okay, so this is the ladder. So here what is given? Come to this sentence. The base of the ladder is pulled away from the wall at a rate of 5 meter per second. So which distance is moving at a rate 5 meter per second? So the base of the ladder with the wall. So this X distance, it's moving, is pulled away from the wall at a rate of 5 meter per second. So it is moving, it is changing according to the time. So how it will be denoted? From that sentence we can denote your dx by dt is equal to 5 meter per second. Okay, when the base of the ladder is 8 meters from the wall. So base of the ladder, which letter we have denoted? That is x. So when x is equal to 8. Okay, it is given. So see that from the diagram, so it is a right angle triangle. So we got the relation x squared plus y squared is equal to 17 squared. So we found the relation and these are the things are given. Okay, so here dx by dt you are having and you are going to find, you see that what you have to find in the first subdivision, how fast is the top of the ladder moving down the wall. Okay, so see that this is the top of the ladder and the what distance here it is used, y. So how fast it is moving down? So we have to find out which one. How fast means it's a rate of increasing. So it is nothing but dy by dt you have to find out. So you take this relation and you are going to differentiate with respect to t. So take x squared. So when you differentiate, it is 2x. But what I told? I told you to differentiate with respect to t. So 2x dx by dt. Plus, how to differentiate y squared with respect to t? It is 2y dy by dt, which is equal to 17 is a constant. 17 squared is also a constant whose differentiation is 0. So divide throughout by 2. So you will get x dx by dt plus y dy by dt is equal to 0. You see that x, you know, x is given was 8 and dx by dt is also given. These two results are given. Now we have to find what in the first subdivision, what you have to find, how fast is the top of the ladder is moving down the wall. That means you have to find out dy by dt. So dy by dt has to be found and we don't know y. So two results are unknown here. So from these two results, we can find y first using the relation x squared plus y squared is equal to 17 the whole square. So you are going to consider the first one. In that, in the place of x, you are going to substitute 8. So it is 8 squared plus y squared is equal to, what is 17 the whole square? That is 289. So y squared is equal to, what is it? 289. So minus, what is 8 squared? It's 64. When you bring it to the right side, it is minus 64. So your answer is 225. So y is equal to 15. Now, so in this relation, what are the results? You know x, you know dx by dt, you know. Now you know y. So we can find the remaining. So take the second equation and substitute the values. Your x. So what is your x? X is equal to 8. What is your dx by dt? That is equal to 5 meter per second. And what is y we have found? It is 15. So when you substitute in this result, you will get this step. So 8 5s are 40 plus 15 dy by dx is equal to 0. So therefore dy by dt is equal to minus 40 by 15. So dy by dt is equal to, when it is divided by 5, minus 8 by 3 meter per second. So first subdivision is over. So come to the second subdivision. What is the question? At what rate the area of the triangle formed by the ladder, wall and the floor is changing? You see that with the ladder, wall and the floor, we form the right angle triangle. So in that, the area of the right triangle, at what rate it is changing, the question is asked. So first we should find the area of the triangle. So what is the area of the triangle? Half into b into h. Your base is x and the height is y. So we have to differentiate with respect to t. So you take a, when you differentiate with respect to t, it is dA by dt. And come to the right hand side, half is a constant. So we have to take it out. And look at x and y, both are variables. So you have to use the product rule. So while you are differentiating, you have to use the product rule. So the product rule is, first variable you have to keep as it is. And the second variable has to be differentiated with respect to t. So it is dy by dt plus second variable you have to keep as it is, and you have to differentiate the first variable with respect to t. So that is dx by dt. So see now, half, what is x? So x is nothing but, so x is, it's given as 8. Okay, and dy by dt, from the first subdivision we have found dy by dt, that is minus 8 by 3, and plus what is y? Y we have found 15, and dx by dt is given as 5. So when you substitute in this result, your answer is minus 64 by 3 plus 75. When you take LCM, it is minus 64 plus 225 divided by 3. So when you calculate, it is 161 divided by 2 into 3 is 6. So it is equal to 26.83 meter squared per second. Thank you, students.